show, Control-Shift-C, L, got all the things going. Sweet. Inheritance, that is the theme for this class. So we're going to learn, of course, about inheritance. We're going to learn about abstract classes, and that was one of the trickier questions during the Kahoot. And then we're also going to learn about casting. So we saw a slide very much like this when we were talking about testing in Java and testing in general. And so inheritance, like unit testing, sort of scales in importance. So if we have a very small, not complicated class structure, inheritance seems pointless. It seems like, why would I want to use inheritance? This makes no sense. And that's fine. I definitely hear that quite a bit. However, as the complexity scales, so does the benefit of inheritance. So what is inheritance? Here is an example. It's a loose cognitive example of how our brains sort of use this idea of inheritance. So here we have a cake. We all know what a cake is. It's like a concept in a sense. And then a type of cake is a chocolate cake. And then there are many types of chocolate cakes. So we have German chocolate cake, chocolate pound cake, devil's food cake, things like that. And so in our brains, we understand that a chocolate cake inherits the properties of a regular cake. It is a regular cake with this additional property of having chocolate. A German chocolate cake is a variation of a chocolate cake. So it's inheriting what we get from a normal chocolate cake, and then it is either overriding, like changing some ingredients, or it's adding other ingredients, things like this. And so already our brains are at least adapted to understand this form of inheritance, because this is just how we talk. So it's no surprise that when we start looking at Java code, we have a concept of inheritance, which does feel useless at first, at least it did for me. But when we start thinking about organizing like larger structures, it then starts to fit a very like recognizable pattern, if that makes sense. So a quick diversion. This section is called This is Super, because we're going to be talking about this as well as super. We've talked about this quite a bit, and this is just a refresher. So this refers to a field or method of an instance of a class, a field or a method of an object. So this is this particular instance. And so, for example, we have two instances of the doggo class. We have Bonsai and we have Sherlock. And so this .name has a different value per each instance of the class. And so if we were to access this dot name for Bonsai, it would give us Bonsai. This dot name for Sherlock, it would give us Sherlock. So it's contextual to the instance. And so here is an example. So here we have a vehicle class. And the vehicle class has a few different fields. It has a static field, which is the max speed limit. This right here, I think, is the speed of light, if Google didn't lie to me. And we have the make and model as well as the year. And so we can see an example of using this in our constructor. So we're saying whatever values we pass in to the constructor, we're going to set that instance, this instance, we're going to set those values. And so it makes no sense to say something like this dot max speed limit. And the reason why that makes no sense to say something like this dot max speed limit is because max speed limit is static, right? Max speed limit is not specific to an instance. It is shared across every copy we make of this class. They all point to the same field, right? So that leads us to this concept of super. Super and this are very similar. conceptually. So like this, super refers to a class, field, or method belonging to an instance of class, to a class's field or method that belongs to an instance of the class. The difference is where the field or method lives. So let's say we have a car class that extends, it inherits the fields and properties of a vehicle class. Super is going to refer to all of these fields in the vehicle class that the car class inherited. So this would be the car class's instances fields, and then super would be the inherited fields. Now, we cannot use super to access private fields or methods. And so there's really only one way that I typically see super used. I see a question? Yes.
So this is only if there's an instance of the class, correct? Like if you use, so if I make a car class, give it, fields and methods, and then underneath it I do super. What if I have two classes in the same? Like I've now done two car classes, and then I use super. How would it know which car class? Maybe you shouldn't make two classes.
Right. So let me see here. There's a graphic here. So we could have an example where we have a boat class, a car class, and a plane class that are all inheriting things from the vehicle class. And so when we use super in each of these, we're referring to the fields here. Now, when we create an instance of car, we're creating an instance of that, a copy of it. And so the fields inside of car, like this dot field, behave the same way as the fields inside of vehicle. They're just all mushed together. Now, I'm going to jump back real quick. So, because we can't just say something like, let's say there's a field in here called, I think we already know the field name. Yeah, like make. Let's say that there's a make field that was inherited from the vehicle class in the car class. If it's a private field, we cannot say in the car class super.make. That doesn't work. And so that kind of leads into this next idea, and this is going to be the number one way in which super is used. Hey. Oh, a wallet. That's important. Yeah, so, sorry to interrupt you guys. No, this is good. Yeah, there you are. Sorry. Nice. Sorry to interrupt you guys. No, thank you for the interruption. That was important. Cool. So, how are we going to use the super keyword? And really the answer to that is also going to be, how are we going to set these fields when we create an instance of the car class? So this is the most common way, and probably the 99% way you'll ever use super, in my opinion. And that is in our constructor, right? And so in our constructor, we will say super, and we'll pass in all of the fields that belong to the parent class. And so what this does is this calls the parent class's constructor, is what's happening right here. After we set the parent class's fields that we need, we can then add our own car-specific fields. And so you can technically access public methods. This might be a bit of a tangent, so try to compartmentalize this. So we can technically access a getter or a setter from the parent class. And we could technically say something like dot, get make or dot set make. Super dot get make and super dot set make. We can technically do that because we have access to it. It's a public class and it's technically part of the super. We could do that. We just technically don't have to because they're public and we have access to them. And so this is a valid way to use super. To explicitly say super.method name, right? If it's public. But typically this is the only way we use super. So I've talked a lot, and I think from how I explain this, it probably is a bit confusing. So we'll stop here and we'll do questions, thoughts, clarifications, anything. Yes?
So would there ever be a situation where something that is extending the vehicle class doesn't have a model, per se? Like, would you still call it in super and then just set the null later? Like, what if a bicycle didn't have a model? They were just the brand and the year that you had information for.
Right. So now this would be an example. If we remember, I'll actually rephrase the question in case anyone didn't hear it. So with, let's say, for example, we created a bicycle class that doesn't have a model number. Maybe it was handmade, right? How could we manage that if we're calling the super constructor without a model? There are two ways we could handle this. Option A is we pass in like a default value, like NA or unknown, inside the super. The other option would be that we edit the parent class and add a constructor that just takes in the make and the year. And so then if we call super then with only two options instead of three, it can be managed at the parent class level, if that makes sense. So those two different ways that I can think of, maybe more, right? Sweet. Thanks for the question. Other thoughts, questions? Yes?
You need a car extended vehicle at the top there, or is it what do you got?
I do need that, yes. Yeah, thank you. And then I'll probably save these edits next time for after, because I feel like I spend too much time making real-time edits. All right, cool. Right, so yeah, I had a typo there. If you missed it, I was not actually extending the vehicle class or importing the vehicle class. Right. Sweet. Other questions, call outs, anything? Yes. Yeah, so we can make as many constructors as we want, and the way our constructors are different has to do with how many properties or how many parameters they have. That's what distinguishes them. Because if we make multiple constructors, which actually there's another typo here. I'm missing the syntax. Basically says that this is a constructor. This slide needs some work, but I may just say, just simplify to this. There we go. So constructor, the way the syntax is that we have public, it needs to be public, and then we have the name of the class, and then we have all of our parameters. And so the only thing that makes a constructor different from another constructor in terms of Java is if it has a different number of parameters. Yeah. Cool. Thanks for the question. Other questions? Thanks. Yes.
This might sound silly, but
Mm-hmm.
all of our discussions on constructors, I've always seen them as, public, obviously. Is
Right.
there any use or benefit if a constructor is made private for some strange reason?
I don't think so. It's an interesting question. So the question was, is there any use to make a private constructor? I don't know how you could ever create a new instance of a class if the constructor was private. You might make like a different type of access level. You might make it like default, like package private, meaning that only things inside this package, inside this folder, have the ability to create new instances of this class. You might be able to play around with something like that. But if it was just private, I don't know how you could use the class because it would be blocked off. Yeah, interesting question. Thank you. Other questions, other thoughts? Yes.
Just to clarify, I thought children could have access to private methods as a parent class.
We should test that. I believe they do not have access to private fields. As far as, well, hold on. Well, yeah, they do have access to the private fields. Let's test that real quick. All right, pull up IntelliJ. I was already working on this. This is going to be what we work on later. So I have a computer class, then I have a laptop class that inherits it. Inside the computer class, I'm going to make a private power on field. And then inside of our laptop class, it should inherit it. And then our program's where we run everything. And here, it looks like it's complaining about me trying to call the power on. But that's because it's private. And so let's see if we can access power on from laptop. So we could say public test power. This is void. Okay. And then we could say super dot power on. And it looks like I don't have access. I have access to power. I have access to power off, but not to power on. And so here's one way to think about it. So the inherited fields, the inherited private fields right here, the only way we can access them from our child class, the only way we can access these private fields are through the public getters and setters, or public getters and setters. That's the only way we can access the fields. Additionally, the only way we can set the fields when we're creating an instance of the class is through the public constructor, okay? And so when we call super right here, this is calling a public method. And when we call something like get make, that we would also be calling a public method. And so with this whole exchange here of inheriting all of these fields, it really is locked down to if it's private, we don't have access to it even if we're inheriting it, at least not directly. Does that help? Cool, awesome, great question. Cool, other questions, clarifications? Okay, great discussion, appreciate it. And that leads us into abstraction. And so if you thought that inheritance wasn't useful, you will probably think this is less useful, although I will still advocate that I think this is useful. Cool, so what is the point? An abstract class is the same as a normal class, except an abstract class disables the option of creating an instance of it. And so if we had a doggo class and we made it abstract and we try to say doggo bonsai equals new doggo quotes bonsai, if we try to do that, it won't let us because it's abstract. And so we can't create objects with an abstract class, which means the only way we can use an abstract class is if we extend it, if we import it with another class. So what's the point of an abstract class? Try to do a bit of a discussion here. I've heard this question asked a couple times. I'm curious from your perspective, how you might articulate what would be the point of using an abstract class? Any takers? Yes.
So there's
Mm-hmm.
And they have the base to build on the, what tires and things like that.
Right.
And other ones you can add in extra features and so on and so forth.
Okay. Right. So the example would be, we see this in many cases where there was like a base class of something that doesn't actually exist on its own. So with some cars, you'll have something like the X class that you were describing, where there's like a sport model, there's like a luxury model, etc. But you can't get a car that's just the X class or something like that. I'm not super up to date on cars. And so identically, when we think about how we would actually structure that in code, if you could never actually create an instance of X class on its own, it probably makes sense to make that abstract. Whereas if you had, from there you could create like the sport model, create an instance of that, that would probably extend the X class, etc. So hopefully that's helpful. Any other thoughts? Yes.
No such thing as just like a vehicle, it's only like types of vehicles.
Right. Yes.
Vehicles have properties that we create, but all vehicles have this problem, but there's no such thing as a vehicle.
Right. Yeah. So kind of building on that conversation, the statement was that there's no such thing as a vehicle. There are types of vehicles like bicycles, cars, etc. But a vehicle is a concept. A bicycle is a type of vehicle. And so in this case, when we're talking about making a car that inherits vehicle, a boat that inherits vehicle, an airplane that inherits vehicle, a bicycle, all these different things, we could create a new instance of a bicycle. But the abstract concept of a vehicle, there's not enough information there yet. And so it's a great starting point, but it is abstract in heavy quotes. Cool. Thanks for the input. That was helpful. And that actually leads right into the next example. So here we can see the syntax for the whole vehicle-car relationship. So vehicle, we have to say it's abstract. Oh, sorry about captions. So with the vehicle, we have to say that it's abstract if we want it to be abstract. And so that's going to prevent a developer from creating a new instance of just vehicle. And so that's actually, it's a good thing to prevent developers from doing things in how we structure things, because someone could be in a hurry, they might not understand all the architecture, might be new to the project. And so by calling it an abstract class, we're being very clear on what it is. And then from here, our car class extends the vehicle class just like it would any other class. Okay, so I'll actually pause on this slide before we get to the next scary slide. Any last bits of thoughts or questions about abstract classes before we talk about casting? Yes?
Visually, an abstract class, would it just look like a private class name and then just like empty brackets? Or would it have anything inside of it?
So visually, trying to imagine like the syntax, what would it look like if we were looking at code for an abstract class? An abstract class could look remarkably similar to a normal class. It could have getters, setters, fields, properties, methods. And those are all intended to be imported. And so, for example, let's say that you have like a field called like year created. That's going to be true for all vehicles probably. That's just intended to be imported by all of these different classes. It's never going to be used on its own in the abstract vehicle class. But when you actually look at the syntax for vehicle class, it's going to have getters and setters and private fields. And it could have a static field, like, for example, the whole next ID, if you remember that whole paradigm where we were incrementing IDs. An abstract field could be a great use case for that too. So they're going to look, in many cases, similar to any other class. Yeah, great question. Thank you. Other questions? Okay. So we're going to talk about casting. I consider this a complex topic. It just could be my own perception. You might find this easy, so don't let me skew your perception. Right, so there's a few different levels of casting. The first thing, real vanilla level of casting, is we can convert data types. So let's say we have a string in Java. We could create a new variable and turn that string into an integer. So let's say, pretend the string was like 100. It was the number 100. In Java, we could cast that to an integer type, going from the string type to an integer type. And so now we have a new variable. However, we cannot change the type of a field or method. So what I mean by that is, let's say we have a string variable called aardvark, and its value is a string of like 1, 2, 3. We can't change the aardvark. We cannot change the aardvark variable with a type string. We can't change its type. We can only create a new variable. So here's a code example of how this might work. We have something called pi double, and it's just pi as a double data type. The next line we have pi string, and we cast pi double to a string. So it's kind of look like it has quotes on it if you were to print it. And then finally, we do pi double double, and that's when we take the string and turn it back into a double. And so here's just a lightweight example of something we did in JavaScript. If you remember, we did use things that said, like, we're going to make this a string, we're going to make this a number. So Java has a similar concept. So what's upcasting? Upcasting is, it's essentially, so I'll just read through this. Upcasting is when we take a class, like the car class, and treat it like its parent class. In this example, a car class is technically also a vehicle class because it extends vehicle. So a car class is a car class, but it also has the vehicle class built into it. So in the same way, a boat class in this example is also a vehicle class. It has those attributes. So here's a really interesting code example, and I think this is a very useful code example. So here we create a new car, Porsche 911, a boat, which is a ferry, and a plane, which is a Cessna. Now we could create a list of vehicles because they're all vehicles, right? They all have this inherited class type of vehicle. And so here, we're essentially upcasting the Porsche car to a vehicle. We're treating it like a vehicle. And the boat, we're treating it like a vehicle. And the plane, we're also treating it like a vehicle. And so in that way, we're able to have a collection of vehicles, right? Now, here is an example at the bottom where we are looping through each vehicle. And so all it does is system println vehicle.engine noise. Cool. So yeah, so this is just I think this is a pretty solid example. Any questions on this? Any thoughts? Anything? Yes. Right, so on the left-hand side, we're able to. This is sort of an example buried in the example, in the sense that array lists extends list. And so we could, for example, say, in this top line right here for car, we could say vehicle Porsche 911 equals new car. And then we're doing the same thing on this line where we say, list of vehicles equals new array list. It's a great call out. Thanks for noticing that. Yes?
Could you talk a little bit more about why you would want to do that like that? And why wouldn't you? So, like, why would you do it as a list instead of an array list in this situation?
Oh, on this line right here?
Yeah, like, what's the advantage of declaring it like
I don't actually know off the top of my head what the advantage of would be in just calling it a list versus an array list. I do have thoughts on why it might be an advantage to have a list of vehicles, to populate it with vehicles. But off the top of my head, I'm not really sure what the argument would be for or against that. Yeah. Yes.
What's the advantage of instead of car Porsche, new car, or right, do vehicle Porsche, new car?
I feel similarly to that about the question about starting with list versus array list.
I feel like it's for later on when
Using interfaces. Right, so that would be next chapter. Right. Cool. So I'm going to assume that we're probably going to get into this quite a bit more with the next class. Cool. But what's worth emphasizing here, though, is our ability to upcast, right, and to create a list of vehicles with different subclasses. Because if we didn't upcast them into a list of vehicles, we couldn't combine different classes inside the same array list, right? Like we can't put strings and numbers in an array list, or yes, I believe we can if we make them an object. We can't do that for a regular array, but where this becomes more valuable is in this example with the for loop, where we're able to loop through each vehicle with the upcasted vehicle type, right? We're going to talk about downcasting in a moment, which sounds terrible. Downcasting, right? Before we do, other questions or thoughts on upcasting? Cool. Downcasting is when we assume a class is actually a subclass. So let's say we have an object with the type vehicle. Say we declare it with the type vehicle, or we just see, like in this loop, we have a collection of vehicles. We don't know if it's a car, a boat, or a plane. Downcasting is when we say something like, vehicle, you are a car, and I'm going to call a car method, something like that. Downcasting is generally not a best practice in coding, although there may be a use case for it. So let's look at this example of this vehicle for loop, where we safely downcast a car, and then we call a special method. So here we have a loop of vehicles. It could be a car, a plane, a boat, etc. And here we safely check, is vehicle an instance of the car class? If vehicle is in fact an instance of the car class, we will downcast it. This is the technical downcasting line. We're saying car, it can be anything at this point, equals, and then we have our parentheses, and then car, and then we have our vehicle instance. And then from there, we can say something like car.accelerate, because maybe that's a special method for the car class. And then after that, we go back to just handling all of the vehicles, and we say vehicle.engineNoise. Right, so I will pause on this example. Give it a second to maybe sink in, or if you have any questions, any thoughts on downcasting, right? Yes?
How would you avoid it? Like you were saying, you should not do it. So in your example, if you needed to go get a method for something in the car class, but you're doing a loop for vehicles,
Right.
tell me how you would not downcast. How would you do it?
Right, so in this scenario, downcasting is the right choice, right? In this scenario, this really is the way that would make sense to access a car-specific method. What's worth noting is that there's like an extra protection here where we have an if statement that checks that vehicle is an instance of car. If we did not have this if statement here, we could be writing bugs into our code that might show up randomly, And so downcasting, I wouldn't say like don't ever use it, right? But it's something that we probably if it's reasonable, if we don't really need to use it, then we'll avoid it. In this example, I don't see how you would avoid it. But if we have to use it, we want to be careful with it and do things like this if statement that says, okay, are you actually an instance of a car? Then if so, we will pretend that you are. Yeah. Thanks for the question. Other questions? Yes.
So does Java know to abstract this car from the vehicle? When there's a vehicle, how does it ever know that's actually a car? Yes.
So this car has been upcasted to a vehicle. It was created as a car, and then it was upcasted to the type vehicle. And so in this for loop, we have things that were created as a car, created as a plane, created as a boat, but we don't know their types. And so in this case, we're kind of stuck not knowing which one of those it is. And that's when we have the scenario of downcasting, where we started with a car, we upcast it to a vehicle, and then now we're downcasting it back down to a car. Off the top of my head, there's probably other scenarios in which you could end up with something needing to be downcasted, but I'm not super clear in my head as far as like an example to give beyond this one. Yeah, but thanks for the question. Does that help at all? Not really? No. Okay. Yeah, sure.
Would you use this to accelerate method on that car? Is that something you're method for car?
Yeah, that would be this example, right? Where before we print the engine noise, maybe we want to do something specific with like the boat or the bike or something. Yeah. Bike probably doesn't have an accelerate method. Some do, maybe. Yes.
What would happen if you downcast it and you didn't know? Like, say you just made everything equal, you never upcast it originally, and then you just said, okay, it's a car now. What would it just run like a runtime error?
Right. So you're asking. So you're asking if we created a new instance of car where we called it vehicle. Porsche 911 equals new car. We created the car that way, so we just give it the type.
Only vehicle. You just say it's vehicle class, vehicle, Porsche, new vehicle, and then you just say,
Oh, I see.
okay, car.
Right. So if we were to try to take a non-abstract vehicle class, let's say it wasn't an abstract, right? We created a new instance of vehicle, and then we wanted to downcast that to car. I'm pretty confident that would crash things because it's not a car. It doesn't have those properties. Right? Yeah. So that'd be like a runtime error or something like that. Cool. Thanks for the question. Yes. Not only abstract classes. It refers to classes that have like a parent class. And so whether or not vehicle is abstract isn't important at this level. So we could create a new instance of car that inherits all the stuff from vehicle. And it's going to inherit it whether it's an abstract or not. And then all of our upcasting and downcasting from there is based off of that. So abstract, the only thing abstract does is it protects the class from ever being made an instance of, having an instance made of itself directly. So it's going to protect us from maybe a developer or ourselves 6 months from now when we forgot about how the program is written. It's going to protect us from creating a new instance of vehicle. It's going to give us an error saying that's an abstract class, and then we'll have to create an instance of car or boat or something else that might be more appropriate. Yeah, cool. Thanks for the question. Great questions. I appreciate this. Other thoughts or questions before we continue? Cool. So we looked at this a little bit. I don't think we'll spend too much time on it because I feel like we've coached this pretty well. So this is the exercise. I feel like I can delete this at this point. And so the exercise, we have a program, we have a computer, and really the goal is to create a laptop class and a smartphone class, and they're just going to inherit this generic computer class. I think we'll just do a laptop class to kind of keep things moving. And we'll call this laptop. All right, and so one question that the exercise has is it wants us to decide like 3 properties and 2 methods that belong to computer that could be shared by different things that are a computer. And it could be anything from a medical device that has a computer, a laptop, a smartphone, a smartwatch. And so I'll just take suggestions. What's a property or field that I could give our generic computer class that's pretty universal? Power? Color. Oh, gotcha. Nice. Yeah, we'll make this private string color. Cool. Another suggestion. Oh, memory, sweet. Yeah. All right. We'll do this as an integer because I want to do this memory in megabytes, so we won't count half megabytes. And then one last field. Brand. Okay. Cool. So now we need a constructor in our computer class. So we'll generate constructor. We'll be setting all of these things. There is one more thing though I want to add to this. It would be really helpful if our parent class managed setting the IDs for all of the classes that inherited, so that we don't have like a smartphone and a computer with the exact same ID. Maybe that's okay, but maybe with the design of our system, we want everything to have a unique ID. So we'll do the classic public integer next. Oh, this is static too. There we go. Next ID equals, we want to initialize this because this is not going to take advantage of getters or setters. And then we'll say private, and then we'll call this integer, then we'll call this an ID. We don't need to set that. And then here inside our constructor, we'll say this dot ID equals next ID plus plus. And so what happens is when our laptop, our medical device, our smartwatch or whatever, whenever that creates a new instance, create a new instance of it, it's going to call this constructor, and the constructor is going to give it another ID. So it could be 9,501, just however it increments along the way. Cool. So I'm leaving something out intentionally. So from here, we want to be able to use parent class extends computer, and then we will say we'll add a new constructor. And so this did all the hard work for us. We can see it's using this super. It's passing in color, memory, and brand. And this is just like calling this constructor right here, except that we're calling it from the context of our laptop. And then real quick, someone provide me with one field that's unique to a laptop that's different from other types of devices like this. Battery size, okay. We'll say battery life, and we'll do it in terms of hours. We'll say integer. Well, let's do double, because like 1.5 hours seems reasonable. Battery life. We don't need to set this, but we do need to set this here. So we'll say double battery life. And then here's where we use this again. We'll say this dot battery life equals battery life. Cool. And so here we have our laptop class that's successfully extending the computer class. And let's just test it out. So we will say, just for the heck of it, because we're messing around with the types here, we'll say computer. Equals new laptop, and then here we will call this gold memories in megabytes. It's going to be a big number, well, unless it's RAM. So let me think here. So that would be like, it's never an even number. I don't know how the multiples work when it comes to RAM, but that's what we got, 16 gigabytes roughly. And then we will add the brand, which we have as Lenovo. Then lastly, the battery life, which we'll call it 4.5 hours. And then Java really cares about semicolons, so we'll use that. Cool, and so now let's just run it and make sure nothing crashes, just in the process of creating this. Yeah, nothing crashed. We don't have any getters and setters in either the child class or the parent class, so we will say, let's try to get the memory. So in computer, I'm going to generate some getters and setters, getter and setter, and then from here in our program, we'll say .get memory. Maybe we should do this in a print so we can see our success, hypothetically. Erase that, and now let's run this. And it gives us the value. And so our class, our laptop class, we were able to access the public methods inside of computer. We inherited them. And so now in program, we're able to say .get memory. So that is just about it. I'll take one question if there is one before we break for studio review. Yes. What do you mean? What about the next ID?
How would do you need to put that in constructor as well?
No, I don't, because it does this programmatically, right? Yeah. So, which is kind of a cool thing that's happening in the background. I don't have a getter for the ID. I could add a getter, and then I can see that get ID, even though I never gave it an ID, it's setting it programmatically. And so we have ID 0, which I kind of expected that to be higher. Yeah, I'll look into that later. Anyways, so we're ready for studio. Thank you all for engaging, and I'll see you back at 8 for studio review.